Um, so we talked about this idea of binary, and the main component and primary reason for binary, as we talked about as well, is computers. It's a computer language number system. Binary meaning two, which referred to the idea of 0 and 1, or a string of 0 through 1s. And like we had talked about it before, the main purpose of there is because computers work in the sense of currents and electricity. It either turns it on or off, and they could do these um, insanely fast. And while it looks and it seems like binary would be a weird, a tough way to be able to keep count of something, and in fact isn't. When you talk about the excessive, the amazingly fast speeds at which computers can process and send, and how fast um, the circuitry flows. Um, so, just in terms of, a past example, the number 101 in binary refers to the idea of 1 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0, which is 4 plus 0 plus 1, which would equal 5. So 101 in binary is the equivalent of 5. We always try to go from right to left in binary, which means that this is 2 to the 0, then 2 to the 1, and of course 2 squared. All right, so it's a bunch of like on-off switch. Now, the octal numbering system is in essence a compromise of binary and decimal number systems. Now, when we talk about these numbers, and maybe most of what I'm saying should be all accurate, but much of our computers initially were things like 8-bit. So when we talked about this idea behind 8-bit, or 8 bytes and so forth, or 16 bytes, it is based off of these new types of numbering systems. Um, so as there's a lot more background, and there's a lot more. I'm not going to go into. We're not a computer programming. If we were doing, maybe some of you are taking computer programming, but a lot of, like I said, the basis for all this is the numbering systems. So basically, and there is one more. It's called hexadecimal. And hexadecimal is actually the more widely used one over octal, but I wanted to cover octal and hexadecimal and just give you the idea of what is actually going on, and how it's another way just to view the mathematics. But in the end, the processes and so forth are much the same. But it's a compromise. So computers 010101, it's very hard to track for us humans of what those numbers are, and computers can't really keep track of a 10 base numbering system as a result. But with octal, the number octal means what?
8.
8. So it means base 8. And as you should know, 8 is the same thing as 2 cubed. And basically, it allows us to utilize processes of 3 bits. And I'm not going to go into too much, but the 3 bits you can see in terms of 2 to the third. We talk about what a bit. These are just the idea of what a bit is how many 0 to the 1s and how long those strings are. So these strings go up to 2 to the third, and allow us basically that for each placement, we end up grouping everything here, where we have, of course, 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and so forth. We're able to keep track of these ones using this idea of the bits. All right, so that's kind of where the idea behind a bit comes from. And you know what? Actually, I'm off by 1 here. I went too many, because 2 squared, there are 8 possibilities within here. So yes, it goes up to 2 cubed, but 2 cubed plus 2 to the 1 plus the options for 2 to the 0 give you a maximum number of 7. And if you include the number 0, 0 through 7 is 8. 8 possible outcomes, 8-bit. All that information you don't really need to. It's not. It doesn't pertain to what we're doing. It's just more of a why and a what. But in the computer processing systems, you might have heard, or you might hear of 8-bit or 3 bits. You might have heard of bytes. All this information comes from this. I really never understood the difference between a bit and a byte until I was really like studying up on the history of this, and that's the difference. So you have the BYTE and then the BIT. It comes from the differences in terms of the number of possibilities versus the number of 0, 1 parts you're working with. So you can do everything the same, and once again, but the options here in an octal number systems work with base 8, and you're still able to get all the same numbers as we did before. And as such, with like a table, for example, the numbers, the options for here are now 0 through 7, 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 and it can go on and on and on. And of course, the same thing being that we read from right to left. And so this is really 8 to the 0, or sorry, yes. This is 8 to the first power, 8 to the second power, 8 to the third power, 8 to the fourth power, and 8 to the fifth power. Now, don't worry, we are not going to be going up into those crazy large numbers. I believe the largest numbers I have for you are, I think 3. Maybe I put a 4, a 4 version of it here. Let me check what I have in here. So of course, this one is 8 to the 0 is 1. 8 to the 1 is 8. 8 times 8 is 64. And 512, 4096, 32,768. Now, for the homework, I think the biggest problem I have for you is a 512 on 8 to the third. So each one of these is giving them the same idea as what we did before. And so it's not simply though on and off switches like with binary. Um, I just want to also just, practically just let's see if you really understand the processes of this. Binary is, of course, the most important understanding. Um, the underlying ideas behind computer processing systems are these different numbering systems. And like I said, so sometimes you might have heard or you might hear something called like a hexadecimal system, and that's when it uses base 16, which is one of the most commonly used numbering systems in the computer. And it's based on the idea of still, and its underlying system, the computer is using zeros and ones, but the way that we are going to, um, you know, bring them together is based on the idea of 16. And now they have, I think, it was the most common, and a lot of it has to do with like encryption, making sure it's secure. So they were 16-bit, and then now they came out to 32. And I think Apple just converted everything to 64 or 32, one of those things. Apple. Let me see what it was. I remember reading that they actually just changed it. So, there was I think they changed it to 32. 16 was used for widely, but because in processing everything in Apple's encryption, they went to like 32-bit. And so there was a lot of apps that needed to convert, and maybe in your time that you realized you've seen some applications no longer worked, or it said something like the the application needs to be updated to the new encryption. Basically, that's it's the organization of the numbering system that is used within them. So just to give you some background information about that. And when the very first phones came around, or when not the very first phones, but a lot of the stuff was like 8-bit or 8 bytes, and then it moved to 16, and then I believe it moved to 32 mostly. And that's just the numbering system that is used in terms of how they are kept together. So once again, these numbering systems are the same. We read it from right to left, and we just add them together. Each of these numbers is going to be multiplied by either 8 to the 0, 8 to the 1, 8 squared, 8 cubed, going from right to left. So for example, can somebody give me a two-digit number in a two-digit octal number, meaning that give me two numbers, and the numbers can only go from 0 to 7, each of the placements. 14. So we note that 14 is not the number 14. It's 14 in base 8 in octal. All right, and we're going to try to determine what this number is in decimal form. All right, so 14 is two spaces, right? And so the first one is going to be 8 to the 0 and 8 to the first. And we're going to multiply the first one by 1. So it's 1 times 8 to the 1 plus 4 times 8 to the 1. All right? What does that give me?
8 and then 32.
No.
No?
8 to the 0 is 1.
Oh, you're right. I didn't see that.
Yeah, so sometimes sometimes we even will redo it as 1 times 8 plus 4 times 1. But really it's 8 to the 0. So it is indeed helpful to rewrite these numbers as what they are over here. But we have 8 plus 8 plus, and what do I get from this? What do I get on the second side? Not looking for final answer right now.
9.
What is 4 times 1?
4.
4.
Oh.
And as Christine has right there in her second attempt, the answer is 12. Okay. Now, it is often better just for you to remember the numbers of what they are. All right. So if in doing your homework, and since they're all going to be the same, for octal numbers are 1, 8, 64, 5, 12. And like I said, we're not going to do anything beyond that. Or you can go 4096 if you want to go an extra one. It might be easier for you to note that these numbers, and these numbers all come from base 8. 8 to the 0, 8 to the first, 8 squared, 8 cubed, 8 to the fourth. All right. So let's do another example. Can someone give me another two-digit? We'll do another two-digit one right now. Actually, let's go to 3 digits. Let's not have the first number be 1 this time. 356. All right. 3, 5, 6 in base 8. And octal. All right. So when I set this up, I got to realize this is going to be something times, now this is 1, 8, so this is going to go three of them, which is 64. So the first one's going to be multiplied by 64. All right. Plus blank times 8 plus blank times 1. And now we just fill in these numbers. So it's 3 times 64 plus 5 times 8 plus 6 times 1. Now we have to do the math out. Okay. So we're going to do the math out. And you kind of almost do still need a calculator on here. So this gives me 3 times 64. Let me do that off the top of my head. 3 times 64. Now, here's another thing I should note. I know my answer is less than 512 because when I go into 3-bit, the biggest number I can, the total maximum number of outcomes is 512, which means the biggest number I can get is 511. Just something to note. So 3 times 64 is 192. 5 times 8, I think we're feeling comfortable with that. And thank you, Christine, for getting that right when I was throwing it out there. 40 plus 6 times 1, 6. Perfect, Christine. And when I add these together, I get perfect 238. So 356 in octal is 238 in the in its decimal number form. So the process is the same, and that's what I'm saying. So that nice thing about this, and like I was saying, that when we did binary, it's the same process as doing binary. Now tomorrow's lesson is I'm going to give you a number like 238, and you're going to go back and convert it into like its octal number, which in this case would be 356. You're just going backwards tomorrow. That's why tomorrow still going to be asynchronous. I'll do a couple examples like I did on Friday, and then tomorrow should be nice. We'll do one last example. We're going to go 4 bytes. Or we're going to go to 4. So 4 bits. We'll do a 4-bit number. All right. I got the one that I got brought up and in the chat to me was 777. 7, 7. Okay. So 7777 in octal. All right. This is going to be 512. All right. So the maximum is 512. So this number is 7 times 512 plus 7 times 64 plus 7 times 8 plus 7 times 1. Questions on how I did what I just did. Why did I choose 512? Why does this process work as it is? First off, given that you did the binary, so let me make sure about that part. If you haven't done binary and then you're looking at this at all, you might be very confused of why we're doing this and stuff. So given that you've done the binary, any questions? Elian, what did you say?
No, I don't have any questions.
All right.
That was.
So we have to do the calculations there. So 7 times 512, and basically you could do this all in one step if you wanted to. And if you just do this and then you give me your answer in your homework. So I want to ask you to show me your work. I want you to show me this part right here. And then you can give me what just the final answer is using a calculator and adding them together. Okay, so I'm going to show you that extra step, but it's not required.
Wait. I do have a question.
Mm-hmm.
Did you choose 512? So did you choose 512 because why 512?
So this is 4. This is a 4-bit, right? And so if I go 4 bits, that gives me right here.
Oh.
Okay?
Okay.
So there's 4 placement values. So the 4th one gives me the 512.
Okay, I get it now.
All right, so 7 times 512 is, 3,584 plus 7 times 64, 448 plus 7 times 8, which is 56, plus 7. And like I said, that part right there, you're not required to show me. You can just give me the first line and then the second line for your homework, in which means you could just do this times this plus this times this plus. Actually, it's a lot easier, but because it's notes, I get 4,095. Now I want you to note that, I could technically write a little small 10 right there, but the idea there is that if you don't see this on the bottom, it refers we have an understanding that we're always working in decimal form. So that 8 tells me we're not in decimal. We're in a decimal number system. We're in the octal number system. So when there's nothing there, it is understood that we are in decimal. That is the number in decimal form, the number like you've been working with for long periods of time.
Mister, if it's in decimal form, shouldn't there be a 0 and a point in front of it?
If you want to put 0.00 and all that kind of stuff. So decimal form, decimal meaning 10. So when we say decimal, we don't necessarily mean that there is a decimal point. So decimal and decimal point are two different things. That's why oftentimes if you go to other countries, they don't actually use a decimal point when they go into the other numbers. They use a comma. So oftentimes you'll see like 4095 comma 21. So they'll use things like that when they put the number, and that actually does in ours typically mean what we use as a decimal point. And that's just some placement values. So decimal does not mean a decimal point. It just means that we're using base 10 for our number system. Does that clear that up?
Yeah, thanks.
Okay. And that's what I have for you today. Your homework, I believe, is should be relatively. I got you 8 problems, going from 2 all the way to 4 in terms of digits in octal form. Show me the work, give me the final answer, and that's what I have for you for today.